Welcome back to the shop. Today we are modifying this sweet little radio, which is called the KT-WP12 or sometimes the KT-9900 from I think QYT. Yeah, that's it. I got this little radio maybe 2 years ago because I saw this nice aviation connector in front and I figured this is probably a fantastic radio for converting for digital mode. I just need to find the microphone, PTT and speaker in that connector and I'm done. Turns out it wasn't quite that easy because there is actually in fact no PTT line in this connector. There are serial lines going to and from the microphone, which is this one. And the PTT instructions are sent over that serial line. So actually decoding and documenting the protocol used from the hand mic to the radio, that would be a very, very cool project, but quite time consuming. So I'm not tackling that at least now. But what we did instead is we have installed on the hand microphone, hand speaker microphone no less, the DB9 connector and wire it with the Kantronics standard pinout on this so that I can connect this radio via this mic to the $3 digital interface. All that is needed is one of these male-to-male 9-pin cables and of course a USB-C to USB-C cable to connect the other side of the $3 DIGI-MODE interface to the computer. And to make sure that this can still be used as a radio, we also installed a small switch. So you can either use the hand mic as a speaker microphone, or you can push the switch up and then the audio in, audio out and PTT are going through this connector. So you can connect it again through the $3 DIGI-MODE interface. Stick around and I'll show you how I did it and we'll do some tests to see that it actually works the way it's intended. As usual, I've done a bit of the work off camera because that's just going to be boring to watch, and usually when I do hardware modifications like this, there's an awful lot of swearing involved. I put the 9-pin connector on the back of the hand mic, and I also put the little switch on the side here, which will be used to switch this from data mode to normal voice mode, so that we keep the normal voice capabilities of this nice little device. What remains to do is solder up all the wires to make sure that we get audio in, audio out and PTT control out of this thing at the back. So let's get started doing that. I've cut the blue and the white wire. Let me zoom in so you can see how this is done, the blue wire and the white wire. If you try to do this modification, the colors might be different and even the placement may be different, but I'm guessing it'll be in the same spot on the connector. If you're unsure, just use an oscilloscope to measure and make sure which one is the audio in and which one is the audio out. I'll have to look at my notes to see which one is which, but we see the blue wire is for the speaker and the white wire is for the microphone. So, good to know. What we will do, we will insert the this little switch. Let's see if we can see the switch. This one. It's a what's called a 2-pole 2-position, I think it's called. So this will switch these two wires between either the connection in the back or the speaker and the microphone in the hand mic. So let's get to work. I've got some wires. I figured we'll try and use some sort of color coordination here to make it a little bit simpler. And I will use, let's see, I'll have to look at the colors again. We'll use the blue for a speaker. That means we will have to extend both of these a tiny bit. And I can probably zoom you out. This is not going to be easy to see at that zoom level. Let's see. So we have to extend both the blue and the white wire to reach the connector, and from the connector we will need to reach back to the blue and white wire or to the connector at the back. We'll also do connections for the PTT. We'll save that for later. I think I'm going to need some heat shrink to seal the connections, so I'll be right back with that. We go. Sadly, I don't have blue nor white heat shrink, but I think we will have to make do with what we have. So I will use at least not yellow or black. So now these wires should go to the center pins of the switch. This might have been better to solder these on before I set the switch, but I did that using glue and that was a bit of a fiddly job. So yeah, I guess I have to fiddle now instead of earlier. Well, we'll manage. I have to tin all. Are you seeing this? Let's see if we can zoom in a little bit. I have to tin all the connections on the switch, preferably without melting the microphone enclosure. Yeah, clearly I should have done this before inserting the switch. But we will have to make do with what we have. Let's see. This thing will... yeah, that's all right. I think I'll just try and put the cable in place before I do anything else, because that's just going to be more difficult the more things we get on here. So to thread this in, you have to just thread one wire at a time through the little slot in the top of this thing, and use probably just the right amount of force, not to break anything. And yeah, this will move in nicely, and there's this little plastic piece that you can use to lock it in place. We're not going to do that quite yet. So these need to go to the centers of the switch. So I'm guessing, yeah, about this long should be all right. We'll cut them there. And tin the ends, still at an appropriate zoom level, I think. I'm removing very little insulation because, at least for these wires, a lot of it melts when you start tinning them. So there's really no point in removing too much. So let's see, let's try and do the blue wire at the bottom. Yeah, this is getting interesting now. We can manage to get that on the center pin. I think we did. And the white one on top. That worked as well. Let's see if we can show you some of this. It's probably going to look like shit under this zoom level, but again, we're going for functional, not beautiful. See if we can maybe get some more light this way. That actually doesn't look awful, I think. let's hope that's good enough. And next up, we will connect back from one side of the switch to the other side of the wires up here. So we'll do the exact same thing. We'll attach the wires again. So we now need to decide if voice operations is going to be up or down. I think, let's say down. That means we will connect these back on the lower part of the switch. So once again, cut them to an approximately sensible length. Remove some isolation and tin them and try to solder them on. Let's try and tin the ends here once more. And now for the really fun part, trying to get these attached down here. Let's see. I don't know how well you're gonna. This is almost impossible to see for me sitting here, so I don't think this is gonna make a very exciting video, but we'll see. That looks promising. Let's see if it sticks. And it does. Very nice. So maybe the solution here is to have some fresh solder. It's a tiny blob when you go and do this. Let's see. See if we can manage this one as well. And I think we can. And at least to my eyes, this doesn't look horrible. I'm as surprised as you are. Very cool. Let's try and see these small beads of solder in here. Let's try and get them out. They can they can cause an awful lot of annoyances, I think. So let's see if we can get them out. That leaves just 2 cables to attach, and these are the ones that will go to the connector in the back. So then we need to figure out which goes where. And I have I'll put an overlay on the screen with this. Let's zoom back out a little bit. With this graphic that shows this. So basically what we have is the blue wire is the speaker. So the speaker of the radio, that would be the AF out, and that's pin number 5, which will go to the sound card microphone. That's right. And pin number 5 on the inside, that is the top right pin as far as I can see. So let's try and attach this to that one. There we go, and that once again we are ready for the blue, which is speaker. So that will go to the microphone, which is, yep, as we said, pin number 5. Let's connect this up. Go on. That worked and looks, I think, acceptable, but yeah, let's call that acceptable. the white one. That will be the microphone. That would be the AF in for the radio. And that would be the speaker for the sound card, which will be pin number 1, which is the top left corner on the inside of the enclosure. So let's see if we can get that attached. And once again, I think we can. And yeah, the last thing to do with these wires then is to connect them back to the switch. The blue wire to the lower pin and the white wire to the upper pin. So remove some well, it is attached. Guess that's something. And I'll try and take a close-up picture, and you can laugh at it when I put it up. That was the audio in and out. So the last remaining connections is the PTT and the ground wire. We'll use the yellow wire for the PTT and the black wire for the ground connection. Let's see if we can manage to get these connected up here. I'm sure you're not seeing any of this. I'm not seeing really much myself. Let's see. Yeah, there we have it. And the last one is the black wire. That goes on pin 6, which is the lower left corner, I guess, depending on which way you're seeing this from. And now there's, of course, way too much stuff in the way for this to be easily reachable, but we'll try our best. Can you see this? No, probably not. This is probably going to be quite the boring video to watch because this very, very fiddly stuff, I can hardly see it myself. So getting the camera in there to show you, it's not going to be easy. Hopefully we'll end up creating a rather cool product though. For the PTT connections, we have to remove the PCB. The actual PTT is going through the serial bus that's going up and down, and also on that serial bus you transfer all the key presses from the front, the up and down buttons, and all the characters on the display. So there's no dedicated PTT line among these 8 cables going back into the radio. Not really a problem. We just have to connect to the solder points for the PTT switch, and that's going to solve it for us. But we have to remove the PCB, and hopefully we'll manage to route these cables in a quite a sensible way around the PCB, so we can actually close this up. It's getting to be quite a lot of stuff inside this hand mic now, but with a bit of luck we'll manage. Let's see. That should be it. See if we can, yeah. We get this out, and I'll do a screen overlay with a picture of this switch to determine which of the connections go to the ground plane and which go to the signal wire for the going to the CPU for the PTT action. This connector is the PTT, and no, so I'm sorry, this connector is the ground, and this connector is the PTT wire going to the CPU. So we will have to just figure out how long these wires needs to be. They're going to curl up like so and around the PCB and the connector here. So I'm guessing we don't want them too long, and certainly we don't want them too short either. So let's hope this is about the right length. challenge now is putting this together without ripping any other wires out, and hopefully getting some sensible routing of the wires. Let's see. Is there room for them to come up there? No, it is not, but there is room for them to come up here, I think. If I just bend them down, of course you're not seeing any of this. Bending the wires down and trying to bring them up where this pin is. See if we can get that to work, or will they take up too much space? Maybe. Yeah, that looks acceptable, I think. Of course, the one wire it slipped out, but yeah, we can just force that back in. And no. Yeah, we'll try. We'll put some screws back in and see if this works. These screws, they're sort of self-tapping into the very, very soft plastic. So it's mostly to keep things from sliding sideways. I think it doesn't really, no, that's not the right hole. I think just the pressure from the enclosure is going to keep this thing in place once we put it together. Let's see, there were 5 screws, so that should mean I should be able to find 5 places to put them. That's 3. And yeah, these ones, of course. Going to be interesting to see if this works at all when we get this back together. I give this about a 50-50 chance. There we go, that's all these screws. So next up we need to place these carefully and put, this is hard to see, we need to put the connector back. Make sure you get it in the right way. There's a notch, big notch in the middle, so that shouldn't be too hard to figure out. And make sure it's seated properly. And then I guess it's just a matter of trying to force this thing back together. Hang on, there's this locking thing here to lock this cable in. Let's see if we can manage to push that into place, and we can. Try not to get any other wires over the screw holes. Try your best to line everything up in a sensible way, and then just forcing the whole thing together. And with that, this should, in theory, be done. We'll have the opportunity to connect for data mods on this one when this points, I think we decided on up, and we should be able to use it as a normal radio with this in the down position. I guess the next thing is to figure out whether or not this works. There is a slow scan television event from the ISS going on this week. I may try and fetch some pictures from there, or if that's not possible, I live fairly far north, so I don't get really brilliant passes from the ISS. If that doesn't work, we'll do some normal APRS on this, and I'll show you that. I'll meet you back here with a conclusion in a little while. As you can see, SSTV actually did work on the thing, but it did not produce particularly brilliant images. I attribute that to 3 different things. This is not the best radio for decoding signals like that. I was doing it from my home in a noisy environment with just a vertical X50 on the roof, and there is no cat control on this radio, so I can compensate for Doppler shift. I got a lot better decodes with other radios and other equipment later on, so I wouldn't consider it as a shortcoming with the digital interface, but well, the fact that it worked at all, I think it's pretty impressive. When it comes to APRS, I have to say that worked a lot better. As you can see from the map, I picked up beacons from quite a lot of stations. This is just after a few minutes of running. As you can also see the output from Direwolf and all the signals coming in and going out for that matter. So for APRS work, I think this worked most excellent, and that was the reason I built it in the first place. It worked quite well for what it is, and I consider this mostly a prototype, a proof of concept. I'll continue this series with creating a $6 digital interface with a bit more features. So if that's something you think you'd be interested in, then please consider subscribing. If you watched all the way to the end and liked this video, please consider giving me a thumbs up. And if you have some comments as to what I did or what I should have done differently, please feel free to leave a comment below the video. Other than that, I'll just say thank you so much for watching, and until next time.